Good evening, friends. So let me take the differential equation dy dt is equal to y plus 2. So we are going to discuss about the picture of the solutions. So we have taken dy dt is equal to y plus 2 by equating dy dt is equal to 0. This leads to critical point or equilibrium point. So dy dt is equal to 0 means y plus 2 equal to 0. So y is equal to minus 2. This y is equal to minus 2. This line every point on this line is the critical point, and that leads to steady state solution. So let me draw the picture. So we are taking this axis as t, and this is y, and this is negative. This part is negative y, and this part is negative t, and our equation was dy dt is equal to y plus 2. So the steady state solution is y is equal to minus 2. Y is equal to minus 2 is the steady state solution. So how will the y is equal to minus 2? So draw y is equal to minus 2. This line is y is equal to minus 2. So if I put here y is equal to minus 2, then dy dt is equal to 0. So slope is 0. So the slope field, this curve also we are drawing, is called slope field. Now if I put here y is equal to minus 1 if I put here y is equal to minus 1, then we get dy dt is equal to minus 1 plus 2 is equal to 1. So slope will be 1. So at y is equal to minus 1, on the line y is equal to minus 1, slope will be 1. So arrow will be like this. That's tan 45. Slope 1 means tan 45 degree. If we take y is equal to 0, then slope will be 2. Then arrow will be slightly upward direction than the last one. if we take y is equal to 1 here, so we get dy is equal to 3. So then arrow will be like this. Slope field will be like this. And now if we come negative part of the y, so this is y is 0 0 origin, this is 0 0, this is y is equal to 0 line, this y is equal to 0. Now if I come here, y is equal to minus 3, y is equal to minus 3. If I put here minus 3, then y is equal to minus 3. Put here minus 3 plus 2 minus 1. So the arrow of the slope field will be like this. So slope is minus 1 means tan minus 45 degree. So which one is steady state solution? This y is equal to minus 2, y is equal to minus 2 is our steady state solution of the given differential equation. dy dt is equal to y plus 2, y is equal to minus 2 is the steady state solution. Now we check whether this steady state is stable or unstable. We check whether this steady state is stable or unstable. So we take we investigate like this. Now if I consider a point here, suppose minus 2.5, then put here dy dt is equal to minus 2.5 will give minus half, that is slope will be like this. And in this region slope will be the angle of the theta will be very small. Angle theta will be very small. So as we move away from the steady state, the slope become larger. Slope increases. As we move away from the steady state, the slope increases like this. So if we stand here, this is the steady state solution. Y is equal to minus 2 of the given differential equation dy dt is equal to y plus 2. This diagram is called slope field, or in another language we can call it space. So this steady state we check this steady state is stable or unstable. This steady state is stable or unstable. So now we observe carefully the direction of the arrows, or the change of the direction of the arrows. The slope increases as we move away from the steady state. The slope increases gradually. The slope increases in lower part also. The slope increases. So if we stand here, we always move like this. So we always move away from the steady state. If we stand here, we always move like this. If we stand here, we always move like this. We always move like this. If we stand in this position, we move this like this. So This is the picture of the solution of the given differential equation. So without solving this differential equation, what we have learned in the BSc, the process to solve a linear differential equation, without using that process, without solving the differential equation, only by seeing the nature of the slope, we can visualize the solution picture. And this is the elegancy of the phase space. This is the elegancy of the phase space. So the solution curve or solution space will be like in this direction. Let me draw another fresh picture. So this y, this is t, this is negative t axis, this is negative y axis, and this is the steady state solution. This is the steady state solution of the given differential equation, and this line is y is equal to minus 2. Now we check whether this stable or unstable. How? We have seen just now. If I stand here, we always move like this. We always move away from the steady state. We always move, and these all lines in this area will be the solution of the given differential equation. Like this. So the phase space or slope field will be like this, and in the lower part so without solving the differential equation, we get the nature of the solution or the solution picture. This is very important topics in mathematics. To study any system, we have to go through this process, and since we are moving away from the steady state, so this steady state is unstable. This steady state is unstable. Unstable steady state. And this process is very important, because any system we have to check whether the solution of the system is stable or unstable. If the solution is stable, if the system is stable, then we can take the system for further analysis. Otherwise, we have to leave the system if it be unstable. So thank you. Like, share and subscribe.